Okay, so today we're going to learn about inverse functions, finding them from an equation. So yesterday we did tables and points and graphs. Today we're going to look at equations. Same basic rule. When you're finding the inverse, you switch x and y. When you solve for y, then you solve for y. So you switch x and y, and then we're going to solve for y. So we want to isolate y. And she describes it as, Ms. Meadow, the peeling away the layers. Did we ever talk about the ogre? No. Did anybody see Shrek? Yeah. What are ogres like? They're like onions because they have layers. So we're going to pretend like y is like, the soul of the little ogre. And we're peeling away the layers. She likes that little story. I think it's cute. Okay. And our new equation, once we get the inverse, this is the notation for the inverse of f of x, or the inverse of y. Now, there's something I tell my students to do that always works. You'll always get it right if you do this. Some people listen to me, some people don't. I don't know why. My students in Algebra 1 have to do something very similar when they solve literal equations, and mine are always able to do it if they listen to just one extra step, okay? And I'll tell you what it is. So the very first thing you want to do is we're going to rewrite the equation, but we're going to switch x and y. So I'm going to write x equals 6y minus 12. The thing that helps my students always is that if you want to solve in terms of y, it's easier for you to move things from left to right. So if you switch it, and not all of you are going to do it, you'll feel like you don't need to, and that's okay, but if you just switch it, because right now I haven't done anything to the equation, because it has an equal sign in the middle. I just put equals x on the end, and now everything I move away from y is going to the right, so that will help you. So now that I've switched it, I need to isolate the y. I'm solving in terms of y, so I have to follow PEMDAS backwards. So what would you do first? Add 12. Good. Now what would you do? So the inverse of y is x plus 12 over 6. And some of you, because it's linear, y'all should, if it starts linear, it's going to be linear. Some of you guys are going to reduce it and write 1/6 x plus 2. Okay, my slope, and then my y-intercept. I would accept either one of those answers. They're both correct. Okay? So let's look at another one. The very first thing we're going to do whenever we're finding an inverse is we switch x and y. And then, because I want to solve for y, I'm going to put the side with y first. So when I move things, I'm moving them from left to right. So what would you do first? Subtract 18. Good. And now what would you do? Okay. Kind of, but we don't want to divide by a fraction, so instead we keep change flip, we keep change flip, we multiply, so we keep 2/3, we change division and multiplication, and we flip it. So that's why they say multiply by the reciprocal. So we're going to do that to both sides, but when I multiply on this side, I'm multiplying that expression. And most of you will probably move it to the front. Either way, though, it really doesn't matter. You'll probably write it either like this. The inverse of y equals 3/2 times x minus 18. Or some of you will distribute because it's linear. And you'll write it like that. Either one of those are correct. Okay, the big thing is, if you stop at this answer and you're taking your SAT, I think that you would know that this answer is the same. If you saw that answer, I think that you would know that that's simplified. So it's good to see different forms of the same thing. So just be able to pick out the one that's the same. So the top two were linear. So the inverse of a linear function is another linear function. This one's a square root. When I find the inverse of a square root, what am I going to get? No, it's going to be, think about what we graphed last night. When you graphed the square root, what did you end up with? A quadratic. So the inverse of a square root, we should end up with a quadratic. So the very first thing we want to do, we switch x and y. Okay. So there's not a lot of math involved in inverses. It's really just rearranging it. Like we said yesterday, it's just rearranging it, kind of undoing the math and writing it in the opposite form. So I always move, if I'm solving for y, I move the y side to the left. What would you do first? Subtract 6. Good, I thought I heard someone say it. Then I have a fourth times the square root of y plus 5 equals x minus 6. So it's similar to solving what we did in the last unit. I'm just kind of following PEMDAS backwards, working backwards. What would I do now? Leo, what would we do? It says 1/4 times 1/4 in the front. Good. Times 4/1, multiply by the reciprocal. On this side, we're going to multiply by the reciprocal. And so I'm left with the square root of y plus 5 equals, and in this problem, it might be a little bit easier to distribute. If you don't distribute, that's okay. I would accept both answers. So from our last solving unit, once you have that square root isolated, how are you going to get rid of it? You square it, so it cancels. Here we're squaring the expression. So now I'm left with y plus 5, just what's underneath, and I have this expression squared, and then the very last thing I have to do is get rid of the plus 5. So I subtract 5. Now, the 5 wasn't over there when I squared it, so it goes on the outside. Okay, so the answer for this one would be the inverse of y is equal to 4x minus 24 squared minus 5. So I'm not really doing a whole lot of math here. I'm just rearranging it. So some people really like inverses because there's not a whole lot of actual calculating. So always check, if you start with a square root, you should end up with a quadratic. Our next one, what kind of function is that? It's a little different. You haven't seen that one before. This one is a cubic. It's cubed. Okay, it looks kind of like a quadratic, except instead of having an exponent of 2, it has an exponent of 3. But because we're just using the inverse rules, even though you haven't studied these yet, you'll still be able to do this. The only thing you need to know is the inverse of something that is cubed is the cubed root. Okay, and so normally we only see square root, which is 2. If it doesn't have a number written as a root, then you can always assume it's a square root. But cubed roots, we always put the 3 on it. So first we're going to switch x and y. Then I would, since I'm solving for y, I would write the y part of the equation on the left. And then we got to move everything away. We got to peel away the layers. What you going to do first? Subtract 2. and then I'm just going to bring everything down. What would you do next? Well, we're trying to peel away the layers to get to the y. We want this y all by itself, that little y. So I want to take things away from it ever. I don't want to do any math. I just want to rearrange it and take things away from it. Divide by 5. Okay, he says instead he's going to divide by 5. Okay, I wouldn't reduce that or anything because like I said, we're really not doing a whole lot of math. We're just kind of rearranging it. So right now it looks like a big fraction. That's okay. So now that I have this isolated, how do I get rid of cubed? What's the opposite of cubed? What's the opposite of square? Square root. What's the opposite of cube? Cube root. Cancels. Cancels. So you really don't have to know too much about cubed roots to be able to do that, except that those are opposites. So now I'm left with y minus 1 equals the cubed root of this big fraction. And the whole fraction is under it. Sometimes people will just write the numerator under it. The whole thing is under it, because the whole thing was there when I took the cubed root. So now I just have one last thing, plus 1 on the end. So the inverse of y is equal to the cubed root of x minus 2 over 5 with that big plus 1 on the end. Because the plus 1 wasn't there when I took the cubed root, so it goes on the outside. What do you think? Do you have questions?